eliminating the human from the environment of the robot, that is when the robot power is on, no human is allowed. Today we are talking about having a safe robot. Safety itself is not a problem. What is difficult is to create a robot that is safe and performant. That is, the combination of performance and safety makes it very hard because these two criteria are always competing. Well, we see on the left a robot that is clearly a threatening robot. On the right, we might think this lighter robot is safer. But in fact, if we think about the way this robot is actuated, we realize that there is a transmission, a gear system that amplifies the inertial properties that are inside the motor and reflect those properties back to the contact. And if we have a contact, we are going to have serious problems. Now, in the last 15, 20 years, there has been a lot of development in the research of designing robots that are safer and that are more compliant. One of the probably best robots in the world today comes from Germany. The DLR group built this light, torque-controlled robot that provides those compliances and reduction of the gearing. The problem, however, with respect to safety, if we are to achieve intrinsic safety, that is, if we want safety that is not only when the robot is active, but if something fails and we want the robot to be really safe, then we have to consider the open loop. And the open loop dominates the impact forces. So we still have to go further, and we still have to deal with the questions of safety in a way where we are making sure that there is no failure that can cause impact and harm to the human. So the addition of compliance in the structure can help, but obviously it reduces the performance of the system. Well, let's see, how many mechanical engineers we have here? Good. So the problem of building safety in a robot, or even the problem of designing a robot that is not as carotide, ends up to be always how we deal with the gravity. And we end up always dimensioning the motors, and this dimensioning of the motors result into some specification of the motor. And then we realize that we need this motor to have also additional performance capabilities, accelerations. And then we place all of these in the robotic system, and we end up with some specification. This is sufficient, but is it necessary? Because if we analyze this problem in the frequency domain, we see that in fact the magnitude of torque needed is decreasing as we increase the frequency. That led us to another approach with the problem of designing the robot. That is, the requirements are, yes, large torques at low frequency, but at higher frequency we might need much smaller torques. And by using two motors, one at low frequency, one at higher frequency, we are going to be able to build a robot that is much lighter. So this is the concept here. We put a smaller motor on the structure. The structure is light, and the large motor is placed away from the structure, the moving structure. Obviously, this is not going to work because the large motor will be reflected, but because this motor is only needed at low frequency, then we can isolate it. And by placing a flexibility, we are able to isolate this motor, and we will not see it at impact force.